All right, let's compare our deployment methods so we clearly understand. So we have our deployment policies and the other deployment methods here. We do talk about blue-green in place in future slides. But anyway, so if we're looking at all at once for the impact of a deployment. If your deployment fails, you're going to have downtime. How do you resolve this? You basically have to deploy your environment again. So this is probably the worst impact you can expect is all at once. For rolling, because you're deploying in batches, if a batch fails, then it's kind of like all at once where you're basically deploying the older version, but now you have a new version, old version, and it becomes very frustrating. Rolling with additional batch is very similar to rolling, but the idea is that you're provisioning new machines at a time. So this is more of an issue if the first batch fails, but everything else, it's similar to rolling. For immutable and blue-green, it's minimal because even immutable is basically using blue-green deployments. The idea is that it's creating duplicate infrastructure, and then you can easily move back to the old infrastructure in the case that the new one fails. For traffic splitting, if a percentage of the client traffic is routed to the new version, temporarily is impacted. So the idea is that you're sending some of your traffic there, and if it's bad servers, then the customers are going to experience some bad traffic, but I think that's okay. For deployment time, all at once is the fastest because it's literally tearing everything down and spinning everything up. Rolling deploys is much slower because you're deploying out in batches. Rolling with additional batch is going to basically have the same amount of time, or probably slower than rolling because you're waiting for the servers to spin up and then switching them over. For immutable and blue-green, this will take a significant more time because you're provisioning a lot more infrastructure, but you get the trade-off is that you're going to have minimal impact. For traffic splitting, it can take longer. It just depends on what you set as that timeout because it's up to you how long you want to have that canary in the coal mine before you determine that it is not safe anymore. Let's talk about downtime. So all at once absolutely has downtime, and the rest you shouldn't experience downtime. And when we say downtime, we mean that there's literally no servers up and running to reach any traffic. And so the only one that could end up in that situation all at once. But you could have unavailability with the other ones because you'd have a reduced in capacity. Now we have DNS change. That's where you have a DNS record and you switch it over. So for basically all of these, there's no DNS changeover. For blue-green, there is. And for traffic splitting, there isn't. So blue-green is very much reliant on the Route 53 level to switch things over from load balancer to load balancer. So that's obvious why there'd be a DNS change. For the rollback process, it's manual for all at once rolling and rolling with additional batch. For immutable, you just terminate the new instance to roll it back. For blue-green, you have to just swap the URL to go back to the old one. It's still a manual process, but you swap it back. And for traffic splitting, you reroute the traffic and terminate new instances. So that one's not too difficult. The way you deploy code to the instances for all at once and rolling is existing. So it's not necessarily creating new instances. It's just the existing EC2 instances. And that's another reason why it's so darn fast is you're not waiting for that provisioning time. With rolling with additional batch, it's creating new ones, new and existing ones. And for the rest, it's creating new. And that's basically why those other ones are so slow because of that new action. But there you go.